Hello guys, so today we are here to solve this maximum consecutive ones, and this problem is an easy problem, but I want to illustrate a very important point, by solving this problem. So without much ado, let's start, solving this problem. So in this problem, we have to return the maximum consecutive ones. So see here, for example, in this array, the maximum consecutive ones appear at this line, this point, okay? So for this, what we need to do, that we need to do declare one variable max, okay? Max, yeah, and max is going to have the running count, and then and then another will be max till now, and this will be also be 0, okay? And now we'll write one loop for int I is equal to 0, I less than nums dot length plus I, and then if nums of I is equal to 0, okay, then in that case we will we will make max is equal to 0, okay? Else we will, what we'll do that we will make max plus max, and then math dot max of max, and then max till now, okay? And we will save this in this max till now, okay? And then we will return max till now like this, okay? So if we do like this, then what is the output that we are going to get? Perfect. So let's submit this. So this solution beats 80.8% of solutions. And this, in this solution, we are only doing one pass, through the array. But what if we, want to improve this? There are obviously solutions which are there, which are better than this. So are they, are those solutions not even doing one pass on the, the array? But that is not possible, for to solve this problem, to get the maximum consecutive ones, we have to, go through the array at least once. And if you are going through the array, even once, then the time complexity of that is, at least it's going to be you know, uh, big O of n. So where n is the number of elements in the array, where n is the number of elements in the array, like this, okay? But this may look a very tight implementation for the solution, but there are within that big O of n range, I mean to say, the other solution which I'm going to show you, that is also of big O of n, but minor adjustment in this logic, we are going to have even better solutions. So let's do that, and to do that, we'll be commenting out this solution, okay? Okay, then we'll write one new solution. So this will be the same, like this. And then again, two variables we need to declare. Max is equal to 0, max till now. This is also equal to 0, and then our loop will be starting from int I is equal to 0, I less than nums of length plus I. Okay. In this case, what we are going to do, that we will be putting one if nums of I is equal to 1, then we are incrementing our plus max, okay? And instead of doing this all the time, this this increment thing, max till now, getting the max out of the two variables. We'll be doing this max thing only here. Okay. Okay. And then we'll make this max is equal to 0. So here on every encounter of 1, we are going to do in this problem, and on every encounter of 1, we are going to calculate the bigger of max and max till now. But in here, only when we encounter a 0, we are going to do this, and but there is a possibility, like see, in this case, the possibility is that, only when we are encountering a 0, we are, doing this max calculation. But after this first 0, we are not encountering any 0 till the end of the array. So in that case, the max value will only be 2, but it should be 3. Okay. So if you see this solution, if you are just returning this value, return max, okay, return max, max till now. Okay, return max till now. Okay, in that case, then if we return only this till now, then what will be happening here? See, this is wrong. Okay, it's saying output is 2, but it should be 3. So if we go to the test case and we add, let's suppose we add even more ones. Okay. 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 So see, this one is only 2 ones, and this one is so many more ones, and it should be actually giving this answer. Then what is the result of the run? See, this is wrong. Output is 2 only, and it is counting only this, but it should be counting this. How to get rid of this? So nothing, nothing wrong in this. We are only doing this calculation of max till now when we encounter 0, and we have not encountered any 0 in this whole range. So to overcome this flaw, what we did do that, at the end of this, we do this math dot max of max 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 till now, like this. And so this is what we are doing uh, at the end. I mean to say, not here, at the end of the loop. We have not come to the end of the loop. End of the loop happens over here. So we should be writing that line over here. So after this, when we run this, see, this is also correct. Output is 33 and expected is also 33. So with this, I hope it is clear that, just by a wise placement of some lines of statement in our code, we can improve the efficiency of code, but I'm yet to demonstrate whether this is efficient or not. So let's just submit it. Perfect. So see, this is 100% better than, this previous solution. So just by, positioning of some lines here and there, we are able to get better efficiency, better time complexity. Uh, in general, both of these solutions are big O of n, because they are, passing through they are doing one pass through the array. But our placement of the logic in this sense, what is happening here, since there are few zeros and more ones are there, so zeros are sparsely populated, populating this array. So this max till now operation will be, happening little less than over here. And this makes sense for us to put it in those cases when when the value at that index is 0. So that's why in that scenario we are computing this max till now value. And once we are doing this problem, this solution achieves better time complexity. So I hope this is clear to all of you. If you have any doubt, please post it in the comments and I'll happily answer those doubts. If you have any better solution, then also you can post your solutions, and I'll be happily, acknowledging those solutions. So with this, I'll close the recording. Happy coding. Thanks a lot.